Welcome back. In our previous videos, we have looked at the complex number, its forms, the algebraic or exponential and polar form, the operations that guide complex numbers, as well as how to construct the graphs for these complex numbers, which we term as the Argand diagram. Now, it's time to now take conversions between complex number forms, which is how can we convert from algebraic form to exponential form, from algebraic form to polar form, and so on and so forth. To do this, we would need the modulus and the argument of the complex number, which we earlier discussed. Now we'll talk about it in detail. As always, please make sure to like, share, and subscribe to the channel. And if you haven't, please turn on your notifications to ensure that you receive posts as to when new content or new uploads are made. So let's begin. Of course, remember that we have said that R refers to the modulus of Z, and then we also say that theta represents the argument of Z. Now, how do we now get into what they mean in terms of their values? Now, for any given complex number in its algebraic form, let's say A plus IB, where A represents the real part and then B represents the imaginary part, we see that from the Argand diagram, we can represent this complex number on the graph. Now, this little Argand diagram above is to depict the representation of this complex number A plus IB. Now, this line here represents the complex number Z with coordinate points A, B, where A is the real part, of course, and B is the imaginary part. Now, what do you notice? You'll notice that this formulation here creates some very, very unique properties. First and foremost, the angle formed between the complex number and the x-axis here is what we refer to as theta, which is in fact the argument of Z. We also have that the length of the complex number itself, or the distance between the origin and the coordinate A, B, is what we also refer to as the modulus of the complex number. So now we are beginning to see exactly where this is going. Now, what else do we know? We also know that by Pythagoras' theorem, this formulates here, of course, a right-angled triangle. And by the position of the right angle, it means that R is in fact the hypotenuse. By the position of the angle itself, it tells us that the vertical distance, which in this case is going to be B, is in fact the opposite, and then the horizontal distance here is in fact the adjacent. That is A. Now, with this concept known, how can we now find the value of R and theta? Clearly, by Pythagoras' theorem, we know that the square of the hypotenuse is equal to the sum of the square of the other two sides. So if we make the hypotenuse subject of the formula by taking the square root of both sides, you would have that the modulus is equal to the square root of A squared plus B squared, right? So this is the modulus of Z. Similarly, by the concept of SOHCAHTOA, we see that if we take the tangent of the angle, we would have to take the opposite divided by the adjacent. So it should be B over A. So making theta sub of the formula, we will now have this to be the tan inverse of B over A. This is, of course, the argument of Z. Don't forget, the modulus can also sometimes be written as this. So this gives you the formulation of the modulus of a complex number as well as the argument of a complex number. These are two very, very important identities as far as complex numbers are concerned. And the reason why they are so important is R and theta form the key ways in which we can write a complex number in polar form as well as in exponential form. Don't forget that in polar form, we have that R is equal to R cos theta plus I sine theta, where cos theta plus I sine theta is of course in bracket. And then we have that Z is also equal to R e raised to power I theta. So this gives us a very big advantage. By finding the value of R and of course finding the value of theta, it becomes very, very simple for us to determine what the polar form would be as well as what the exponential form would be. Now let's take an example to showcase exactly what this is. Now let us consider the complex number to be root 3 plus I. Now in this case, let us first convert to polar form, and then after that we will convert to exponential form. So to polar form or to exponential form, remember the most important thing we need first is the modulus as well as the argument. Now don't forget that the modulus is the square root of a squared plus b squared, and then the argument is the tan inverse of b over a for a complex number in the form a plus ib, which means that if we compare coefficients, it implies that a is in fact root 3 from the question, and then b is in fact 1 from the question. So for the modulus, we would have the square root of root 3 squared, then plus 1 squared, which would give us the square root of 3 plus 1, which means that the radius or the modulus is the square root of 4, which in this case means that the modulus is 2, right? So the radius in this case is 2. Do not forget that we are taking the positive value, right? The positive value of this radius, right? Now, we will then move on, of course, to the argument. Theta would, of course, be tan inverse of b, which is 1 over root 3. 1 over root 3 gives us a special angle when considered in the terms of the sine, the cosine, and of course the tangent. In this case, the special angle gives us theta to be equal to 30 degrees, right? Now, when writing in polar form or in exponential form, we prefer our angular values to not be in degrees, but in radian values, right? Do not forget that pi rad is the same thing as 180 degrees, which means that if we take the value in rads for 30 degrees, that would be 30 pi over 180, which would imply that theta would be equal to pi over 6 rads, of course. So if we put that together, the polar form would then be z would be equal to the radius, which is 2, cos pi over 6 plus I sine pi over 6. And then if we were to take the exponential form, now that we already know the polar form and of course the modulus and the argument, we will know that z would of course be r e raised to power I theta, which implies that z can be written as 2 e raised to the power of I pi over 6 as the exponential form. So this shows us that once we have the modulus and we also have the argument, we can utilize that to convert any given algebraic form of a complex number into the polar form and of course into the exponential form. Now, of course, it's also important to note that there is a relationship between the exponential form and the polar form, right? If you look at these two concepts, clearly it shows that e raised per I theta is equal to cos theta plus I sine theta. This is also a common series representation when discussing the Taylor series of or the Taylor-Maclaurin series of the exponential function, right? So this shows you that if you have the exponential form, you can always convert it to the polar form itself. And if you have the polar form, you can always shrink it into the exponential form. So now we have talked about the ways in which we can convert complex numbers from their three types of forms, which is from algebraic form to polar form to exponential form. Now let us now go in much detail as regards to more operations that can be carried out as far as complex numbers is concerned. We are talking about what happens when we want to multiply a complex number by itself, right? We know that for a real number, if we take 3 multiplied by 3, that's 3 squared, which gives us 9. So what happens when I take z as a complex number and I multiply it by z? That gives us z squared, yes. But then how exactly would that z squared be written? Okay, what exactly happens when we also take the root of a complex number? For instance, we can take the square root of a real number, the cube root of a real number, and so on and so forth. What happens when I also take the root of a complex number? This would lead us into discussing the De Moivre's theorem that guides complex numbers. This would be done in our next video. As always, please like, share, and subscribe to the channel so that you don't miss any of our content. Also turn on the post notifications so that you are informed whenever a new upload is made. Thank you.